Bonjour et bienvenue à cette leçon de les mathématiques avec moi, Monsieur Jennings, et mon petite fille.
Bonjour, comment ça va?
We're actually going to do the rest of the video in English, so a lot of you just breathe the sigh of relief. Oh, he's going to talk to us in French. My goodness. Okay, let's put ourselves up here, Zara. I don't think we'll need that area of the screen very much. We're going to do these types of questions. No, because I'm going to need to draw, and I might even have to do that with my elbow. You see, so the place you've chosen, boom, it's a dangerous place because there's going to be math that happens really fast. Fast math. Okay, so speaking of fast math, here are the types of skills that we're going to do in the Delta Math today. This one is find the growth or the decay percentage. So here is something, this is definitely decay. It's going to get smaller as I increase x, and this is decay by 75%. How did I know that? Okay, well, I know that when we have, there it is there. Hey, yeah, that's right. You can read. That's very good. You can read algebra. It's good practice for a grade 1. Okay, so if I have y is equal to 28, doesn't matter what number is there. 0.25 raised to the x, well, I create this number here. This number is my b, and b is composed of 1 plus the percentage change as a decimal. Okay, that's important to remember. And so if this was 1 plus something, that thing must have been negative 0.75. Okay, another way to think is if I have x is 1, that means like 1 year or something like that, then I will multiply this by itself once. This means just is itself. I'll multiply 28 by 0.25, and I will get 7. It will be 75% smaller than 28. So this here is the answer to the question. 1 minus the rate of change is equal to 0.25. Well, I was saying like it's plus, right? But then we're going to get a negative answer for r. We understand that that negative answer means that it's a percentage decrease. Okay, so how would I solve this? Well, I would subtract 1 from each side. And that would give me r is equal to 0.25 minus 1. The answer is 0.75, and it's a negative number. So that's 75% decrease.
Okay.
Let's see if I'm right. I'm right! And then it's very important to go in here. This is less than 1, so it is decay. I get this. It was 1 minus r. This was minus a 0 and 0, blah, 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 blah. Okay? They say decay is we're going to use minus r. I just think it's plus r because I like doing things with the same sign. And when I get a negative answer, I know that means it's decaying. Okay, so that's how I'm different than the rest, but it's the same thing. Let's look at another example. So we have 58 to 0. So this is again decay, and it's going down by 0.24. 24% increase? No, decrease, decay. Yeah, there we go. Submit answer. Yes. Yay! No problem. Okay. This is an increase of 3.4%. Okay. Oh, how does he do it so fast? How does he do it so fast? Because I look at the number and then I just move the decimal place and I subtract 1 from the number. So it's not particularly challenging. You just need to know what you're looking at. Growth 1.034 is more than 1. Yeah, that's right. It's this much bigger than 1. Okay. So for the blah, blah, blah. So that was 1 plus r at some point in this number's lifetime. It was 1 plus r, and the r, therefore, would have had to been 1 plus 0.034. 0.034. Well, what is that as a percent? 3.4%. Okay, let's move on to another skill. Okay. If you have questions about that, don't be shy about asking me, even if I just sort of suggested with my sarcasm that it's pretty easy. Okay, let's look at exponential rules level 1. Okay, I saw a lot of people wanting to look at these types of questions in class. So let's copy this one out. My first step would be to write it down. And also I want to make a note that this wants positive exponents in the answer only. So if I have 3 divided by 6, I know that that's 1 over 2. So done, final answer. No, there's more to it, Mr. Jennings. 3 multiplied by v to the 5 raised to the power 4. Oh, that looks like an exponent law type of thing. All divided by 6v to the 5. Okay, this is equal to, let's just get this out of there. I was just joking around. So I know that 3 over 6, that's 1 over 2. So I just have v to the 5 to the 4 over 2 multiplied by v to the 5. I've just gotten rid of that 3 over 6. It's now 1 over 2. V to the 5 to the 4. Well, here I do v to the 5 multiplied by 4 because I'm raising a power to a power. So this is v to the 20 divided by v to the 5. And then I just do this is v to the 20 minus 5. That's my division of powers rule, all over 2. That gives me v to the 15 over 2. Submit, done, final answer. Absolutely 100% correct. No chance I made a mistake here. Well, maybe if I don't put the fraction right. That answer, yes, yay! And then you look at it, and you say this here, blah blah blah, this there, blah blah blah. Okay, v to blah blah blah. And then you minus, yeah, okay, sure. Oh, and it's got the reason why I'm not seeing things is so they have little eyes. It's the first time I've used those. That's really cool. Look at all this feedback that it gives you. Use the software to learn. Your goal is not to answer the questions. Your goal is to learn. Okay, here. So 6w to the 8 over 2w to the 4 to the 4. So that would be 4 to the 4 to the 4. That's w to the 4 to the 4. That's w to the 16. I multiply on the bottom. Then I have 8 over 16. So then I'm going to have w to the negative 8. But then I just put it on the bottom as w to the 8. And there's going to be 3 on the top. So this is 3 over w to the 8. Submit answer. Yes. Yay. And then look again. Nous avons gagné! Oui, nous sommes les vainqueurs de ces problèmes de mathématiques, oui! Okay, let's keep going. Okay, so that's that level. Let's see if level 3 has some harder things for us. Oh, look at that! Oh, it's so gross. Can you imagine he makes us answer that? When are we going to lose this, Mr. Jennings? Yeah. Yeah, right. When are we going to use this? So, you just need to know how to answer these types of questions because you need to be able to work with exponentials really well to simplify your exponential functions and so on. Start by copying out the question. 15r to the 6, c to the negative 8 over 3r minus 3c, all raised to the power negative 5. Okay. Equals 15. I can't do 15 and 3 together yet. I can't do that division because I have to do this exponent first. Do your bedmas first. Okay, so this is 15, r to the 6, c to the negative 8. Wasn't that what we just had over there, Mr. Jennings? Yeah, I can't do anything to it yet until I do this. I mean, I could move the c to the bottom, but I don't have to. Okay, so this is going to be 3 to the negative 5, r to the negative 3 times negative 5. This is r to the 15. And then c to the negative 5. C to the negative 5. Okay, now this is equal to 3 to the negative 5. Let's bring that to the top. That's 3 to the 5 on top. That's a really big number that we're going to have inside the solution here. I'm a little surprised that they have such a big number. 3 to the 5 on top times 15. There's no numbers to cancel that out with. Okay, sure, fine, I'll do it. I'm going to use a calculator. I don't actually remember. It's like 216 or something. No, it's 243. It's 3 to the 5. 243 times 15. Do 243 times 15 in your head. Well, I could do it, but I'm not going to do it right now. R to the 6, c to the negative 8, all over. I could simplify that, really. R to the 15. I've only done one thing. I need to pay attention to what I'm doing. Okay, so now 3 to the 5, that's 243 times 15. I'm just going to put that in brackets. And then I have r to the 6 minus 15 is r to the negative 9. And c to the negative 8 minus minus 5, that's c to the negative 3, all over 1 equals, well, 243 times 15 is just use your calculator, Mr. Jenny.
Gagner, non.
Oui, nous allons gagner si nous utilisons le petit ordinateur, le calculateur à main. Comment on dit en calculateur en français? So let's first just do the whole thing. Clear. 3 to the 5 is indeed 243. multiplied by 15 equals 3,645. Of course, 3,645 is a beautiful number. I use it all every day. 3,645. I need a little more space here, so I'm just going to drag that up. I'm going to move that r to the 9, c to the 3 to the bottom. R to the 9, C to the 3. How did I do that? These were negative exponents. I can kick them to the bottom and just change the sign of the exponents. Okay, I know you're winning. I know you're winning every day. I know it's like you've got tiger blood, but please don't interrupt constantly the math lesson, or else my students might get more frustrated with me than they usually are. So let's put this in here. 3, 6, 4, 5. Yes, I know you're winning. R to the 9. Oops, that's not R to the 9. To the 9. C to the 3. Submit answer. Yes. Yay! Okay, what did they do? C to the 8. R to the... So they brought this in the same way. 3 to the 5 they brought up. Okay. And they color code. Isn't that beautiful? Let's see. What do they have here? Move factors with negative exponents to make the exponent positive. If you want, you can do that. I don't mind negative exponents. I'm used to it. It's easy to add and subtract negative numbers as positive numbers once you know that they're just numbers in different directions. Okay, so that's that skill. Not so bad. All right, maybe there's some challenging things in here. I'll try and get like a foil one. Foil one here. Is there some foiling ones? No, they're not going to give you a foily one here. It's looking pretty good to me. You know, when I do this, I solve them in my head and then I move on. No, I'm just kidding. I can't do it that fast. All right. Anyway, it's not that bad. Exponential functions basic. A new car is purchased for $20,800. The value of the car depreciates. Please keep your drinks away from the computer because that depreciates the value of this computer very quickly. Okay, the car is purchased. Is that price? So that's my initial value. I'm going to write this down. I need spacing. The value, the amount of money that the car is worth is a function of time. It's a time-based, time domain function. And then it's equal to the initial value, 2800 multiplied by this growth factor. What's my growth factor? 1 minus 10.75%. That is otherwise known as 0.8925. Do you not trust me? Do you need me to show you? Okay, fine. Here's how you do it. 1 minus. You need to see the numbers. 10.75 is a decimal, so 1 minus 0.1075 equals there. Okay, that's what it is. All right. So how do you do that fast in your head? Think about the numbers and what they mean. This is a little more than 10%. It's almost 11%. So it's going to be around 89. It's a little bit bigger than 89 because 11 would be exactly 89. How much? A quarter of a percentage less. So that's my growth factor. Okay, that's how I do that in my head very easily. 8925. Sorry, when I say it's very easy, it's not to say that it should be easy for you. It's that you too can aspire to that level of ease. All right. Now, what will the value of the car be to the nearest cent? Wow, they really want the nearest cent that the car is worth. Like, gosh, the nearest cent. As though that's significant. They just want to see if you did the math right. Oh, so this is, sorry, you're going to want to know what the value of the function is at 5 years. 13, Mr. Jennings, 13. I'm not even going to erase it. I'm just going to do this like it was a pen. Okay, A at 13 is equal to 20,800 times 0.8925 to the 13. Punch it all on a calculator. Clear, clear, clear. Oh, I had that number right there. 2800 times bracket 0.8925 end bracket raised to the power 13 equals $4,742.10. Oh, they created a rounding question to see if you know to round. This is 10 cents, not 9 cents. I bet if I put in 9 cents, they will say, you're wrong. And I'll say, come on. I don't need the value of a car to a dime. Maybe to like the closest $50. closest $100 would be fine. Like if you told me the answer was $4,700, I'd be like, full marks. Because you know what? You're selling a car. No one asks for pennies. Hey, you forgot 3 pennies. The deal's off. I'm not selling you my car. No way, man. Anyway, that's your answer. Put it in. Answer. $4742.10. Submit. Yes. Yay! Exponential function rate. Oh, the rate. Look, they express the rate as the decimal. They do B is 1 minus R. So they do that and they get 0.0. Look, they did the same thing I did. Because that's what you do. Okay. New problem. Let's see if we get some different problem types in here. Okay. No, it's the same type of problem. Yeah, so let's do this one. Same problem type. I'm just going to do it. Okay. It has mass 6. So this is, we want to know its mass is a function of time. Okay. And that's equal to the initial value multiplied by 1 plus the growth factor, 1 minus the decay factor. Okay. So that's going to be 0.727. Right? I don't know. Let's see if I do this right or not. And I want to know this to the nearest at the 9 minutes. So it's going to be evaluated at 9. I'm not going to rewrite the whole equation. You know what I'm going to punch. So punch it on your calculator. 670 times. I did not check my mental math on this number. I'm pretty confident. So I'm opening myself up to making a mistake here. Raised to the power 9. Times, somehow I lost 670 equals 38.00. I'm going to try 38. Sounds about right. Actually sounds like too much. Oh, oh, and then Mr. Jennings, you didn't do the right thing. That is, I think it's right. Okay, so let's see. Sorry, what was the number? Oh, man. What was it? Where is it? 38. 38.0. 38. Let's try. Let's see. Let's try it. Yeah, I did it! Yay!
Engañé!
Nous avons gagné encore! Oui! Yay! Oh, yeah, I'm so pleased. Look, I got that right, even though I didn't check my mental math. Okay, there we go. So now, last problem type, half-life and doubling time. And a lab experiment. We're gonna have lots of lab experiments, doubling times. 2,200 bacteria, don't do that, please, are placed in a petri dish, or petri dish if you prefer. When I was in high school, when I was in high school, I had a band called Petra's Dish. It wasn't very funny. Okay. The conditions are such that the number of bacteria is able to double every 6 hours. There's a doubling time, doubles every 6 hours. How many bacteria would there be after 13 hours? Well, there'd be times 4 and a little bit. Let's find out what? A little bit. To the nearest whole number. Okay, so we don't want fractions of a bacteria in this question for some reason. Here's how you set these up. We know that the amount is a time domain function. So we say amount is a function of time is equal to the initial value. And it's going to double every t minutes divided by, it says t hours divided by 6 hours. Okay? And now I've been asked to find what's A at 13 hours. Well, that would be 2200 multiplied by 2. How'd you get that number, Mr. Jennings? It told me it doubles every 6 hours. So if I put 6 there, that would be 6 over 6 is 1. 2 to the 1 is 2. So I'd be doubling this number after 6 hours. If I put 12 there, it's going to double, then double again. It's going to be times 4. That's why this number goes there. It's also in the note that we took about half-life. It's the same idea. Doubling time is the same as half-life time. It's just reciprocal. It's just the growth version of half-life. So, okay. So what are they doing here? 13 divided by 6. Okay, now that's what I punch on my calculator. Clear, freshen this up. 2200 times bracket 2 end bracket raised to the power. Let's put the power in brackets as well. 13 divided by 6 end brackets equals that many bacteria rounded to the nearest whole number. It's 9878. 9878. Submit answer. Yes. Yay. Okay, so you want to master these types of questions. Why do you want to master these types of questions? Well, if you've watched this far, I hope you're closer to mastering this type of question because it's a very important type of growth that we haven't studied much yet because we don't trust grade 10s and grade 9s to have sharp algebra skills like you all have and to be able to deploy the exponent laws like you all can to solve these types of problems like you all will be able to after you do some practice. Things like amount of bacteria or amount of money or amount of views of a viral video. These all grow exponentially. Money, as inflation keeps going, 1% inflation doesn't sound like that big a deal. $100 last year is now the same thing, is worth $99 now. Oh, well, that's not such a big year. Actually, it is because over time, all that money is not worth anything. But exponential growth of money is pretty exciting, right? So you want to understand these things because so many things grow with multiplication instead of grow with addition in our world, and they tend to be very important things that drive things like pandemics and stuff, or and govern things like money. So I hope this video was helpful to you. I hope that when you do get frustrated, you will send me emails with screenshots of these problems and the things you want to learn. And oh, there it is, blah blah blah. Right, it looks the same as what Mr. Jennings did. Oh my goodness! And that your practice will be fruitful. That you'll be in touch with me if you need any help. And I do wish you all the best. Bye for now, everyone. Have a great long weekend.